Good morning, dear students. Welcome back to the virtual classroom. This class will be an extension of the previous class because last class we were discussing about the outside class definition. So this class we will do the differentiation between inside class definition and outside class definition. This will be the differentiation between the inside class definition and the outside class definition. When you look at this member function getData, I have not taken the other two, that is void calculate, void output. I have just taken only one member function, that is getData. This getData is inside the class. So this member function is defined as well as declared inside the class. So just for a comparison, you need to look at this place. That is, void getData is written inside the class. That is, this is the semicolon, closing of the class, void getData. This void getData is declared and defined outside the class. Previous class we spoke about scope resolution operator. So today we would like to go little more in detail about scope resolution operator. So when you look at the inside class definition, the declaration part of the member function is inside. At the same time, the definition is also written. That is, we know that a function header has three parts: return type specifier, member function name, as well as the arguments. That is, this will be the return type specifier, return underscore type underscore specifier, and then we have the member function name or the function name. So this is the function name, this is the member function what we have, and then within the brackets we are going to have the arguments arg1 comma arg2 and so on. So this will be the syntax: return type specifier, then I have written member function. Instead of writing here, I have written here member function, and then arg1 arg2. This is the function header. So the definition and declaration is together written inside the class. So when you look at the whole sequence, both are together coming inside. The point here you need to know is, whenever a member function is inside the class, that will be called as an inline function too. Because last class I said about the complex nature. A function, when it has got the complexity, or if it is a complex bound coding what we write within the function, we cannot write complex coding inside the class, or a member function having a complex code cannot be written inside the class. Rather, it should be written outside, or outside class definition is the concept we are supposed to use. That is, declaration of the member function and then definition. This is the definition. So when we look at the syntax part for outside class definition, the return type specifier comes there, return type specifier, and then we have the class name, class underscore name. So last class we spoke about the scope resolution operator, and then you have the member function which is belonging to the class simple interest. That is, getData is belonging to simple interest, and that getData has been declared inside but defined outside. This is the actual difference between the inside and the outside class definitions. When we use the scope resolution operator, this defines, or this is an important operator which says that this getData belongs to the class simple interest. Because a program may contain n number of classes and the same name. For example, there are 5 classes in a program and there is a getData member function, the same name may be used by all other classes also. So there may be member function which is called as getData by other class. So what we do is this scope resolution operator resolves the complexity, saying that this getData belongs to this particular class. That is, this getData member function belonging to this particular class. That's how the scope resolution operator is used, as well as it signifies about a member function belonging to a particular class. So this is how the differentiation between inside class definition and the outside class definition. I spoke about the access specifiers: private, protected and public. Let me give an instance or an example. I read this in one of the textbook. That is, if a person goes to the hospital, the first point of place to go to the hospital is the reception, or the person will go and meet the receptionist. The reception is a place where many people come for their registration. So this place we could call as public. Likewise, when the person takes an appointment with a doctor, he goes and meets doctor in private. So that becomes the private. Public is the place of reception, and the second point is the place where the patient is going to meet the doctor is private. If the patient moves on to the ICU, then that place becomes protected. The 3 different aspects we see. Access specifiers are of 3 categories. One is private, public and protected. In this context of example, I have taken public, that is the place where people go and register themselves, many people can meet, that is public. Secondly, they are going to meet the doctor in private, so I call that as the private aspect. And the third is the protected, when a patient moves on to the ICU, that becomes the protected part. Likewise, here in this example, the private data members, P, T, R and SI, they are the data members under private access specifiers. They will not be accessed outside the class. That is, whenever members, that is, we know 2 members are there, data members and member function. When these members are not supposed to be accessed, I would like to repeat, when these members are not supposed to be accessed outside the class, then we'll be writing those members under private. They are not accessible outside the class. It is the opposite nature of public. In case of public, the public members will be accessed outside. If you see the previous example, I had written about void main. Here I have given just an instance of an example, that is getData written inside and getData written outside. I have not written the void main, because void main is a place where we create the object. When we access the public member function, we accessed through the object from void main, because objects were created in main outside the class in fact, and then we accessed the member functions through the object by using dot access operator. That was dot access operator. That is, example, S is the object and I would like to access getData, so I say dot getData. For example, if this PTR were written under public, I am able to access that PTR. For instance, I say public here, so I'll take this place, I'll write as PTR, which is declared under int, and these data members are, suppose these data members are under public, then I could say S dot P equals, I'll take as 5,000. That is the principal amount. So S dot P equals 5,000. This is accessible outside the class. So the context here is, if at all we want to access private members can be accessed through public. So public is get data, and in public member function the private members have been used. So PTR are the data members under private which are accessed in get data, and these members are accessed indirectly. That is, PT are accessed indirectly from get data, and we are going to work on the private. Hope you are able to understand what I am saying. So private and protected are quite similar. Private will not be accessed outside the class, likewise protected also, but there is a little difference, and we will be working on that example at the later stage. But for the time being, we need to understand that the members which are under private will not be accessed outside. Rather, I would like to say, whenever we want to bring the concept of encapsulation, when we want to bring the concept of data hiding, we need to use the concept called as private, or the access specifier private. When we don't want the private members which are not supposed to be accessed outside the class, then we write these members under private. Likewise, public can be accessed, because some members we need an authentication, some members we need to be accessed outside. That's the reason there is public. About inline function, any member functions which are written inside the class will be called as the inline function. And when we write that inline function concept outside, we may have to use the keyword inline, but that is there in the next chapter. But we just contemplate only on the basic part. So only I am working on the basic part. So this member function will be the inline. The inline member function will not be complex, it will be simple. Only simple coding can be established within the class. So the next example we are going to deal with is a practical program. The first practical program, here we will be understanding the logic part as well as the outside class definition. So the program will be programmed to find the frequency of presence of an element in an array. So we are taking the array and we are dealing with this program. So you know the definition of an array. An array is a collection of elements or group of elements of the same data type under one single name. This is what we discussed in the previous class, or in the beginning of the classes, what we did. So today, first thing what I would like to write here will be the logic part. First we deal with the logic part, then we construct the program. So I begin the preliminary part of the program, that is hash include iostream dot h and hash include conio dot h. Likewise, we begin with the class, and the class name will be frequency. Class name will be frequency, and then we declare the variables under private. That is, under private access specifier, we are going to declare few variables. And what are these variables? Now let us understand the nature of the program. Frequency of presence of an element in an array. Frequency of presence in the sense, how many times, or what is the frequency of occurrence of an element in an array. That is, how many times an element is present in an array. This is what the context is. Based on this context, we are going to work on the program as well as the variables what we want. So since we are working on an array, we want an array. I would like to take that array as, we are going to take an array. I'm just going to mention the logic part now. The things what we require is an array. So I take an array and the size, a standard size we take as 100. Next, I want to find the element, a particular element, whether it is found or not. That is, how many times that element is found. So I need one more variable for element, that is ELE I have taken. That is to find whether this ELE is found. If it is found, how many times it is found. So to count the times, we have a variable called as frequency, or you can call that as a counter also. Count also you can use, how many times that is present. So these are the three important things what we want. But when we speak about an array, with this array we want two more variables. One is I, the other is n. N denotes the total number of elements what we are going to accept in an array. Likewise, I signifies that indexing. So i's value will be starting with 0. To construct the program, we want a for loop. When we work on an array, we need a for loop. So we move on to the logic part, taking these variables. I begin with frequency. That is, frequency equals 0 I take. This FREQ is the variable, taking with the value, initial value as 0. This initial value we take 0 because whenever we allocate memory for a variable, garbage value will be considered by the computer. That is, some garbage value will be initialized. That garbage value will be removed by initializing that with 0. So we will be initializing the value with 0. Frequency equals 0. Next, after that, we need the for loop. For int I call, because I am declaring dynamically the variable I in the for loop. In the previous class or the preliminary classes, I said that C++ allows us to declare the variables anywhere within the program, wherever we want. So for int I equals 0, hope you know this 0, 0 being the indexing value of an array and the first indexing value we begin with, and then I less than n. I less than n, n denotes the total number of elements. Though we have declared 100 as a standard size, we will be accepting 5 or 6 or 7 elements. So n denotes that 5 or 7 or 6, whatever the number of elements we are going to take it in n. I++, this will be the updation. I++ denotes updation and for updating the indexing value. Further moving, I would like to write a condition. That condition will be if the array name A of I equals ELE. If A of I equals ELE, that is the element which we are going to search, that element we assume that we have considered, and then we compare with A of I. So I's initial value is 0. So I would like to take an array here and depict the tracing part. 0 index, first index, second index, third index and fourth index. That is, n's value is 5. 5 meaning 5 number of elements. We are going to accept 5 elements. Let us imagine we have taken something like 5, 8, 5, 10 and 5. These are the elements we have taken. So here what happens, when we are traversing through the array, we will be visiting each element. This will be the concept from a chapter called as data structure. There we see two techniques. One is a searching technique, the sorting technique. In that searching technique, two categories are there, linear search and binary search. Likewise, sorting, the other categories we'll be discussing in the future classes. But here, the traversal concept we use for visiting each element. If we find an element, we consider that count. That is, this element is found. We make a counter to be incremented. That's the reason we are using frequency. And frequency's value is 0. So these elements, when we have taken in an array, let us imagine the control flowing. I equals 0, A of 0. A of 0's value is 5. And then ELE. Let us consider ELE as 5. Let us consider ELE as 5. Then that is A of 0 is 5. ELE is also 5. Once again, I would like to re-emphasize, we have taken an array. We have taken the ELE to be searched, the element to be searched as 5. And when we have taken this array, we go through this array from the beginning till the end, or we call as traversal. Traversal meaning you begin from one end to the other end, visiting each element one after the other. So when we visit elements one after the other in an array, then while visiting, we will be comparing the searching element, whether it is found or not. For example, I have taken ELE equals 5. Now this moves on. 5 is compared with 5 and we note down, yes, it is found. Then we take a counter. Counter was 0. Now it is 1. So this counter, which is taken as frequency FREQ, when it becomes 1, that means 5 is found, or the presence of 5 is 1 time. And further moving, I increments. So this I's value becomes incremented, and then I becomes 1, and A of 1 will be 8. And further it moves on till the end. Let us focus on the logic part as well as the execution. As the control enters FREQ, the counter is 0. Then for int I equals 0, I is a variable used for indexing, and the initial value what we take is 0, 0 less than n. So 0 less than n, n's value for us we have taken as 5. So 0 less than 5, true, enters. If A of 0 in the beginning itself I have taken 5, so that we have a count. So A of 0 is 5 is equal to 5, because the searching element is 5, it is found. Then we increment the counter FREQ plus plus. FREQ plus plus. So when we take FREQ plus plus, there is a count incremented. So 0, 0 will be making it to 1 or updating it to 1. Then the control moves back. When the control moves back, next I increments. I becomes 1. Then 1 less than 5. When 1 is less than 5, it's true, enters again. A of 1, what is A of 1 there? 8. Will it match? Will it compare? It will not compare, because A of 1 is 8 and the searching element is 5, so it becomes false. 8 equals 5 becomes false, it will not enter. So then comes back again, and again it moves on to updation, I plus plus. Here in this I plus plus, I was 0, now it is 1, now it is going to be 2. So 2 less than 5. And then 2 less than 5 is true, enters again A of 2. What is A of 2 there? 5. So 5 equals 5, true. Then the counter increments. So you need to note down, only when the searching element ELE is matched with the element found in the array, then only the control enters the if clause for incrementing the counter. Frequency was 1, now it is going to be 2. So that is frequency, I'm going to write here, frequency equals 2. Next, moves on, I increments to 3, then 3 less than 5, 3 less than 5, true, then enters inside, A of 3 is 10, 10 equals 5 is false, it doesn't enter, rather the control comes. So you know the for loop is there and the body of the loop will be this. If you want to use a floor bracket here, you can use, so minimum one statement should be there, that one statement we consider as this, because if clause requires minimum one, likewise this if clause and frequency makes as one single statement for. So as it moves on to progress, I plus plus becomes 4. So now it will be 4, 4 less than 5, true, enters, A of 4, A of 4 once again it is 5, 5 equals 5, true, enters, frequency is incremented, frequency becomes plus 1 and it will be 3. So frequency started to be from 0, then 1, then 2, then 3, whenever it is compared and matched. That is frequency right now it is 3. Now what happens? It moves on to I plus plus, I becomes 5, I becomes 5, 5 less than 5 is 5 less than 5 will be false, then it moves out. When it moves out, the output what we get is frequency being 3, that is the element 5 occurs 3 times, that is 3 times. The element 5 occurs 3 times. This will be the output. Otherwise, when we go, if this ELE is something like we take as 9, is 9 found? There is no 9. So here what happens, when we take the same logic or the same coding part for us, frequency equals 0, I equals 0, 0 less than 5, then 0, 0 less than 5, then A of 0 is 5, compared with ELE, we have taken 9. So doesn't match. Likewise, this 9 is compared with 8, it will not match, 5 it will not match, 10 it will not match, 5 it will not match. When it doesn't match, we understand that 9 is not found. So the output will be, when you give the searching element that doesn't exist in the array, we need to show the output as this element is not found, this element doesn't exist. That will be the output. So 3 member functions we are going to construct, and already this is the coding, we are going to use it for the logic part. So 3 member functions we will be having, and I am going to write the variables as well as the member functions. So private int, the array I am going to take A of 100, then int ELE, comma FREQ, and one more we want, that is n, A of 100 comma n, n denotes the total number of elements what you want to accept, and then ELE will be the searching element and a counter FREQ. Then the member function will be void get data semicolon, because we are going to have the outside class definition. That's the reason I have taken the declaration part of the function header. So void get data semicolon, next void, then I have find FREQ. I have taken a function name called as find FREQ, that is find frequency. Then void I take as display. Instead of output, I have taken display. So in case if you want to say output, you can use output. Let us try to use different names. In fact, so void get data, instead of get data you can say input also. So void for us here, void get data, void find frequency, void display, these are the 3 member functions declared inside the class and we need to define it outside the class. So I take the closing flower bracket and say semicolon. Further moving, we are going to work on the outside class definition concept. Logic part, outside class definition, both together we are going to learn. So dear students, I want you to construct the program now. I have given you the logic part, and then here is the member function. Here, after closing the class, we will be beginning with the first member function, that is get data, and you know how to write void, the return type specifier, then the class name, that is frequency. After that, scope resolution operator. You know the significance of the scope resolution operator that defines whether this member function belongs to this particular class. Likewise, we have the get data member function name. So here you are going to establish the coding part, that is cout, enter the number of elements. So here cout I take, enter the number of elements. So this number of elements will be considered by a variable n. So C in n denotes the total number of elements what you are going to accept, and then cout enter the elements, that is enter n elements, enter the elements. We are going to accept n elements. So I need a for loop, because we will be accepting the number of elements in an array. I need a for loop for I equals 0. In fact, I need to take here as int, as the logic part says, int I equals 0. That is, I is not declared anywhere, and I is declared as a dynamic variable wherever we want, as I said before, and here I need this. So I have taken int I equals 0, then I less than n, the same kind of for loop, then I plus plus. This for accepting the elements. So n elements we are going to accept, and then we are going to take as C in A of I. So A of I will be accepting the n number of elements, and then the final input will be enter the searching element, enter the searching element. That searching element will be ELE, searching element will be ELE, that is C in ELE. If you observe this, so I have closed the flower bracket. If you observe this, cout enter the number of elements, n elements you are going to accept, usually 5 or 6 or 7. Then enter the elements. So this loop is going to run n number of times accepting those n elements. If you say 5 elements will be accepted. So C in is going to run for or repeat 5 times using this for loop, accepting all the elements, and then enter the searching element. As I gave you an example, ELE was 5. Here I have written the logic part. I want you to construct the program. So when you construct the program and write, make sure that you are going to write once again the function header for the second member function, void find frequency, and then furnish these codings inside find frequency. Then for display we are going to have in the next class. So make sure in the next class I will be working on display, but if possible, please make sure that you are going to construct the whole program. So dear students, this will be the assignment for you. Thank you. Have a good day. God bless you.